Okay, last class we did discuss about virtual interface. Okay, what is the use of virtual interface? How we are using the virtual interface, and which condition we are using the virtual interface. Right. So virtual interface is used to communicate between the static world and the dynamic world. Okay, static world is nothing but interface, module, all these things. And dynamic world means your classes like test-bench components, all these things. Okay. For that purpose, we are using the virtual interface. And then scheduling regions. We have pre-code region, and then reactive region, active region, inactive region, okay, NBA region, pre-NBA region, post-NBA region, okay, reactive region, post-NBA, post-reactive, pre-reactive, okay, so and then post-code regions, different regions. Okay, programming blocks are executing in reactive region, and test bench also executed in active. So all the components are executed in main components are executed in active region, and assertions will be sampled at pre-code region and evaluated at which region? Evaluated at observed region. Okay, so different regions, all the regions we are using because we are executing different programs, different blocks like initial blocks, always blocks. All these are executed in parallel. Okay, I want to avoid the race condition. We will go for the scheduling. Okay. Now today we will discuss about SystemVerilog programming block. What is the use of programming block? Okay, so programming block is also it's like a test bench code. Okay, whatever the code we are writing, it is also like a test bench. Okay, but why we are going for the programming block? Okay, so generally DUT is driving some output. Okay, so we are getting some output, and TB, that means test bench is driving the input, and DUT samples the output. Okay, so that means test bench is reading the output from the DUT, and then test bench is giving the input to the DUT. Okay, then at a time both the DUT and test bench want to communicate each other. Then we will get a trace condition like I want to give the input like this, data equal to 1. Okay, so in my DUT I'm giving some value like data equal to 1 we are giving. Okay, in module also we are accessing the data. Then who will give you the output or DUT when we are giving the output? Okay, all the blocks are executed in active region, right? Most of the blocks are executed in active region. If we have any other regions like TB is executed in reactive region, I think test bench is executed in reactive region. So then all the things are executed, then go for the test bench. Okay. So that test bench is also accessing the same time means we will get a race condition. To avoid the race condition, like data equal to 1 is driving by the DUT, and then same time test bench also reading the data data equal to 1 at a time. Then what will happen? Race condition will be occurring because DUT output is driven, then only the test bench need to start the reading, right? Simple example. Suppose I am writing something on board. Okay, so just I am writing something, anything like output equal to some two. We are writing. Okay, so I am not completed it, but you are reading the data. So just I am writing here out equal to like this I have given. At the same time, you also started reading. Then what I am writing here, you don't know. Okay, incomplete the task, right? So I am also writing at the same time, and you also reading at the same time. Both will be getting the race condition. To avoid that race condition, that's uh, what is the use of main purpose of programming block to eliminate the race condition between design and testbench. Okay, testbench code is executed in reactive region. See, testbench code is executed in reactive region, and most of the codes will be executed in which region? Like active region, NBA region, and then inactive region. In all the regions, most of the codes are executed. DUT code, most of the code is executed in active region only. And then, if anything left, it will go to NBA region. If anything left, it will go to postpone region. Okay, so that's what maximum the codes will be executed in the above regions, and then test bench is executed in reactive region. Okay, programming block also executed in the reactive region only because it is also related to the test bench. But instead of writing the test bench, we are writing the programming block. This programming block will be instantiated in your test bench. Then first the programming block will be executed. After that, it is going to the test bench. Okay. So then it is avoiding the race conditions. So to understand programming block, you must understand the program problem they are solving. That means the problem is race condition. So when you are getting the race condition, you are driving the input, you are sampling the output like out equal to 2, and then same time test bench is also trying to read that output, then we will get a race condition. Okay, so to avoid that race condition, we are using the programming block. This programming block is like a test bench code, but instead of writing the test bench, we are writing the programming block. This program block will be instantiated in your test bench, like how we are instantiating the modules in our module. Wrapper and creating. APP, APP module is there, AXI module is there, I2C module is there. I want to combine all these three modules. Then I am writing one top module. In that top module, all the instantiations will be there. Okay, there is no functionality, only the instantiation. That is the hierarchical modules we are designing. Same way, here also, the programming block we are writing, and then that programming block will be instantiated in your TB. Okay, so program block we are writing. So instead of writing the test bench, I am writing the program block. Okay, this program block will avoid the race condition because after completion of the DUT, then only this program block will be executed. Okay, so without I'm not writing anything on board, how you are reading? Okay, so same thing. I'm writing something here. My writing part is completed. Then only you can start the reading. Otherwise, race condition will be occur. I'm not writing anything, you're not reading anything. Okay. So then the race condition may occur. Okay. See, that's what. Both the initial blocks are executed in active region. See, here also initial begin block is there, here also initial begin block is there. Here writing is not completed, he is reading here. Okay, the data displaying means reading, right? Getting the data. Here I have not completed the data. Then simulator may schedule them different order. Like sometimes data equal to 0, sometimes data equal to 1. That means I am initializing the data. My simulator will remember the first data only. While the initialization, I am not assigning any data, right? Just initialize the data type. Initialization is not like a data assignment, right? So we need to assign some data. In the initial begin block, I'm using that some data and writing. At the same time, in your test bench also, you are reading the data at that derived simulation time only. Because all the initial blocks are executed at t equal to 0 time only. Okay, that is the reason I am getting the race condition. Clear? Then this program block were introduced. So to avoid the race condition, after completion of the RTL, then only this program block will be executed. See, in SystemVerilog, we have RTL. Okay, RTL should execute first. Then only the test bench should react afterwards. That is the reason test bench will be executed in reactive region. Okay. So then the test bench will be executed after completion of the DUT. Okay. So once DUT is writing completion, then only it is executing that. Okay. Same thing. Program block also executed in reactive region. Okay, so which occurs after the active NBA all these regions. Then in active and NBA region, inactive region, all these regions your RTL is executed. Okay, no doubt in that. After that only your programming block is executed. Then it avoids that. Thus, DUT finishes all the updates before the test bench reads the signals. Okay, I have given all the inputs. You need to write the example. Just I am giving the paper to you and then asking again means what is the use? You are giving white papers only. Then nothing I am receiving information. Zero only I am receiving. Or something. Just I am giving the paper and distributing to the all the person, the first person written something. Only something I am getting the data. Then all the students are not completed their exam. Then what is the use of conducting the exam, right? So don't do the test bench and then DUT signals driving and then input sampling will be don't do that at the same time. Driving is at different time and sampling is at different time. That means writing should be done first, then only reading should be happening. Okay. You want to put some data in your system from the pen drive. Pen drive is still copying the data, then another person is asking the data. Without copying that, without pasting the data into your system, how can you read the data? Right? How can you get the print from that? So that is not possible, right? Same way here also. The programming block will be executed in the reactive region. Then you will be getting, you will be avoiding the race condition. Okay. So before that, your DUT will be executed. Okay. First compilation is done, then only simulation will be starting. If your DUT is compile free, then only it is going to the simulation stage. Otherwise, it's not going to the simulation stage. Okay. Same thing here also. What it is doing here? Where does program block executes? The program block executes in reactive region. That means above regions active and NBA regions will be executed. So what I am remembering, so what is the, they will ask you which region this programming block will be executed. So end reactive. So just I am remembering this one. Okay, end reactive. End reactive means A means active region and N means NBA region and the test bench will be executed in reactive region. Okay, our programming block is executed in reactive region. That is unreaction. Okay, just simple purpose and remembering. So how AND operation is there, right? A means active, N means NBA region, and then your test bench will be executed in reactive region. And programming block also executed in reactive region. Then first DUT updates first, then only test bench reacts later. That's the thing. Okay. Simply, I'm talking something, and you're also asking something means, am I completed? My talking is completed completely? No, right? Then you are asking in between them. Then you will be not receiving the data properly. So glitch will be happen. So same thing. See here also he is saying that how we are avoiding this race condition. See the DUT is driving the input sorry output signal 1 and then test bench is also programming block is also reading that block. Okay, this program block will be executed in reactive region. Okay, so this is executed in reactive region, and then this will be executed. All these things are executed in active region, and then other regions lock NBA region. All these regions are executed. Then DUT is updated first. After that, programming block is taking place, and then your module will be having like DUT instantiation, and then what is this TB? This TB means programming block. Okay, programming block instantiations will be there. Then your TB is not driving anything. Okay, not giving any inputs, and not it is reading the data from the programming block. Okay, because I have instantiated that programming block in my test bench. Yes. So then this race condition will be avoided because the programming block will be executed after all the regions, because it is executed in the reactive region, because it is related to test bench block. See, test bench versus programming block. Okay, same thing. So programming block is executed in reactive region, but your test bench is executed runs in active region. Okay, so then this module will be module TB is executed in active region, and your DUTs also most of the conditions will be executed in active region. Then it may get race condition. So to avoid that race condition, we are using this programming block. These programming blocks will be executed in reactive region. After all completion of active and NBA, then only it is going to the reactive region. It avoids that race condition. Okay, no race condition. Understood, right? Race condition means two people are working at the same time. That DUT and test bench. DUT and test bench, two people are working at the same clock edge means I need to consider who? DUT or TB, right? Same thing here also. So the door is capable to go out two persons at a time. But four persons are at a time they are moving means then five may get occur, right? So same thing here also. So that is the detailed race example how we are getting the race condition. This module DUT and then output equal to 2 and then module TB. This is also output is 2. Sometimes may pass, sometimes may fail. Okay, but most of the cases it is failing, right? Because I'm not seeing the output equal to 2 because my DUT is not completed yet, but still I'm driving that output value equal to 2 and I want to read the data. So then the program will be failed. Why? Because DUT is executed in active region, then RHS is also evaluated. So what is that? RHS evaluated in which region? This is also active region. RHS is evaluated in active region, right? But updation will be happened at updates updation will be happened at in which region? NB region. Means it is taking some time, right? But your TB is also executing in active region only. Then how I can read the value? I need some time, right? Because we are having the active region here and then NBA region here. Here output equal to 2 value will be evaluated and then updation is taking place. Updation it is taking some time. Okay, so I'm not updated the value. Then you are not receiving the value. That is the problem. So then I may get output reaches to the 0 value here. Okay. Then because NBA hasn't happened yet, then NBA region out equal to 2. That will be too late. So then I'm not receiving the value of output equal to 2 at my test bench. I'm receiving the 0 only. Because similar to seeing that initial condition only. To avoid that, again I'm using the programming block. Okay. This programming block will be executed in the reactive region. That reactive, after the execution of programming block, it is going to what is the test bench, because this program block I have instantiated in my test bench. Okay, test bench is executing in active region only, but it is seeing the programming block. But the programming block is executed taking some time. In between that, I will complete my all the activities from my DUT side. Okay, clear? I'm repeating more times. Okay, so then you need to remember in a good way. Okay, same thing. Top module I'm writing here. In the top, what are the things I'm writing here? So same signals representation. This is my DUT instantiation, and this is my program block instantiation. Okay, so program block instantiation and then DUT instantiation. After that, this TB will be executed. Okay, same thing. Here also I'm writing some adder example related to DUT, and then programming block I have written, and the same thing. See, this is the example for adder, right? So yeah, a comma b and sum, and then sum output I'm getting a plus b. After that, always com I'm using. What is the use of always com? The combination circuit. Okay. Instead of always at the rate star, I'm using the always com. Okay. So because system Verilog provides that always com, always latch, always flip flop, all these things. So I'm writing the programming block. Same thing. So we can write some tasks in also programming block also, and assertions also we can write in our programming block. Okay, so what we are writing here? Task send packet, and then initial begin and send packet I am writing here. Okay, program block can also contain tasks, functions, assertions, variables, initial begin blocks. Okay, we will write assertions also. Okay, some assertions like you need to check some condition. Okay, so they will give you like that. Some acknowledgement is there. Acknowledgement will be followed 1 to 10 cycles. After that, after one cycle, the request will be seen low. Okay. So in this way, they will ask you the questions related to the assertion. For that, we need to write the assertion. That means my acknowledgement will be high. Up to that, it is followed high 10 cycles. So then, up to the 10 cycles, I need to see my acknowledgement high. After one clock cycle, the request will be low. That means request is followed the acknowledgement, then the acknowledgement will be low at 11th cycle. We need to check that assertion is happening or not. For that, we are writing the assertion. Here, I am writing the simple example like request and grant. The request will be high, okay, then only the grant will be high. Without requesting, how can we grant? Okay, someone gives you the request, then only you will be accessing that. Okay, someone asks you something, then only you will give it, right? Without asking how you are giving, you don't know what they are thinking. They will ask you, or they will ask you something. They will ask something. Okay, ask someone. Okay. So this is the programming block, the clock synchronization. That means with respect to clock also we can write that. Okay, because it runs in which region? Reactive region. So RTL is updating first. After that, the programming block will be react seconds. Okay, because it is executed in the reactive region. And programming block and interface. Like interface handles also we can represent in our programming block. You know interface, how to represent that. What is the use of interface? Interface bundling the all signals. Instead of connecting individual signals, I'm bundling all the signals and group together and place it at one place and calling that all the signals through handle. Right? Simple example, your bag. Your bag is carrying, you are carrying the handle only. But in your bag, laptop is there, charger is there, mouse is there, and then pad is there, and then some mobile charger is there, and then some other things, pens, all these things, and books you are keeping. Okay. Individually you are carrying with your two hands means it is not possible. Right? Then in your bag, if you want to add something means you can add it. Or if you want to remove it, you can remove it. Right? So then there is no problem. The bag will not be changed because the handle will not be changed. Whatever the components are there, all the components will be carried through handle only. Same way here also I am having some interface handle. Based on the interface handle, I can add the different signals, I can remove the different signals, and then I can call in my DUT as well as programming block. Then there is no effect in that, right? So that's what. So just this is the programming block, and then we have an interface. In the interface, request and grant is there. Okay. If request equal to 1, then only my grant will be 3. If you are requesting and then grant is waiting for that. Without request, if you are waiting means, then what is the use of that? Right? Nothing will be there. Suppose I said that today I will come at 9:30. Okay. Then you are waiting. There is a reason. Because I said already I will be coming at 9:30. If I not coming at 9:30 or waiting here, so then what is the use? Right? Same thing here also. The race condition will be occurred, nothing will be receiving at the output side. Okay. And program block with also clocking block because in your interface the clocking blocks are also there, right? And then mod ports are also there, right? What is the use of your taking the clocking blocks? I need to sample my TV signals before the blockage and then driving the signal set after the blockage. Then the two things will be happened at different time of intervals. Okay, we will avoid the race conditions. Okay, and then why we are going for the module ports? Mod ports is gives you the direction to the DUT signals. Then multiple drivers or multiple signals are working on the same interface, we will get a race condition. Okay. To avoid that race condition, we are going with the module ports. The module ports driver is driving the different signals depends upon the direction. Whatever the direction you mention in your DUT, based on that, your driver is okay mentioning the signals, right? And same way, monitor also. Monitor always reading the signals from the DUT. Okay. So in DUT, based on your requirement, you are representing the input-output signals. Okay. Understood, right? The difference. Same way, the programming block is also uses that clocking blocks. Okay. Same thing here also I am using the clocking blocks at the rate passage clock and then I am giving the signal. See, request is the output, grant is the input because in your DUT request is the input, grant is the output. Okay, for the TV it is changing the signals. Request is my output, grant is the input. Okay, because I am requesting to the DUT. From the DB, the request is an output signal. Okay, I am driving the request to the DUT. Then DUT is producing some output, that is grant. Okay, from the DUT, the grant is an output, but coming to the DB, grant is an input. Okay, understood, right? Because test bench is reading something from the DUT. The reading means I am receiving some inputs from you. Okay, writing means I am giving some uh, data to you. Okay, so that is the difference. Understood, right? Same way, I'm using the programming block. That programming block, sorry, clocking block. How we are instantiating that? Interface dot clocking block dot request. Suppose mod port you are using means interface dot mod ports dot. Okay, your mod ports. Some driver you are mentioning. Interface dot driver dot some request. Okay, so in that way I'm instantiating. Now, one thing you need to remember, your program block cannot instantiate your DUT. Okay, in your DUT, we cannot instantiate because you're asking, sir, we are instantiating our DUT in your TV. Then why can't you instantiate in programming block? So because the programming block cannot drive the DUT signals. Okay. So it is executed in reactive region. The EB is driving that signals. Okay. So based on that, the programming block is executing something that means reading the data. That reading will be placed in your TB. Okay. So that is the reason the programming block cannot instantiate your module. Okay. So if you are instantiating your module in your programming block means it gives you the illegal access because programming block cannot contain so another programming block. Okay, so because of in your module another instantiation is there, in your TP DUT instantiation is there, but in your programming block another programming block is not there. Okay, so that is the reason we are not instantiating. So cannot contain another programming block, another interface, and UDP, user uh, user datagram program. Okay, so that means UDP is also not there. Clear? So just see the summary for the programming block. Modules are executed in active region. Programming blocks are executed in reactive region. Okay, and then all the RTL activities will be executed in active region and then NV region. Okay, then your programming block will be goes to the reactive region. Remember the regions. Okay, and this ensures that test bench always sees the final value because stable DUT outputs and prevents the race condition between the design and verification code. Design code and test bench code, we are avoiding the race condition because after completion of all the DUT activities, then only you can read it. Otherwise, you can't get the value. Clear? See this code, just I am executing the interface and then programming block. My module is adder, just A, B are the two inputs and sum is the output. Assign sum equal to A, X or B. Okay, and then end module. So this is my DUT and then interface I am representing. If you are considering the interface, then the interface adder interface I am taking here, then I am not representing any signals in my programming block. I am calling through interface only. Adder interface. My interface name is adder interface. That's the reason I am not explain any program to the interface. Okay, just whatever the signals are there in your DUT, all the signals you can represent in your interface. Okay, because the signals will be taking place as an input or output based on the data type. Okay, here logic data type only we are representing, because this logic data type, it is converting whatever the continuous assignments and then procedural assignments you are taking. Based on that, it is converting that. Okay, and then programming block, what is that? Automatic test is the programming block name, and adder interface, some virtual interface I am mentioning here, VAR, because this programming block is the test bench related to that, and then DUT is related to static in nature. So to instantiate that, I will use this virtual interface VAR, or this is normal interface only, because I am not representing any virtual keyword in front of the adder interface. Just interface handle I am taking that VAR. Instead of VAF, you can take that IF also, interface, or INTF. Okay. So because this is an SV test bench only, right? So not the UVM test bench. So then just module and interface test TB only I am writing. Then there is no need of virtual interface. Okay, when you are using the virtual interface, your classes you are writing, right? Based on the classes, you will be use the virtual interface. Okay. Then I'm driving the signals vf dot a equal to 0, 0, 1, and then 1, 0, and 1, 1. So instead of writing every time display, we can use the dollar monitor also. Okay. So dollar display AB values and sum value vf dot a, vf dot b, and vf dot sum. I'm instantiating all the signals. Okay, then your module TB top, so what you are having, interface handle, and then DUT instantiation. Interface instantiation, it is getting the all the signals, and then programming block instantiation also, because I'm not writing anything in this TB. I have written all the things in my test programming block. Okay, the programming block instantiation is there, means it is going to, this is test TB, so that is your test name. Okay, programming block name. Okay, so that test will be going to execute here. Okay, clear? Then I'm running this one. So while running, you need to select that System Verilog language, and then the tools you need to select VCS synopsis. Okay, so then you can run it. See the signals what you are getting: A equal to 0, sum equal to 0, A equal to 0, B equal to 0, sum equal to 0, A equal to 0, B equal to 1, sum equal to 1. Okay, XOR operation we are getting here. Okay, understood, right? Programming block code, how we are executing the programming block. Next, so casting. This time we want to see the casting programs. Okay, what is meant by casting? What is the use of casting you are considering? Um, Casting is nothing but to convert one data type to another data type. I want to convert bit data type to byte, or byte data type to real, and real data type to integer. Okay, that is the purpose we are taking the casting. Okay, casting is that converting data from one type to another type. Okay, so one type to another type means, if you are taking that some uh, string data types, I want to convert that string to integer. You already see in your strings, I am converting ASCII to integer, or hexadecimal to integer. or decimal to integer or octal to integer. Okay, so that is called as casting. Casting is just like a kilogram to pounds we are converting, or Celsius to Fahrenheit we are converting. In your BTech time, in Z programming, first program Fahrenheit to Celsius conversion and Celsius to Fahrenheit conversion. Okay, so then we are converting that. That is the one data type is represented, and then it should be converted into another data type. Then simulator can use it correctly. Whatever the data type you are using, that conversion is taking place. Okay, so don't don't change the genders. Okay, just change the casting only. Okay, so sometimes you are thinking male, you are converting to female, female, you are converting to male. It's not happening, right? So just you are converting the data types, strings to integers, integer to strings, and then that byte to bits, bits to bytes, all these things. Okay. So what is casting? Imagine you have an integer data type, okay, and then real data type. So you are equating those two. Is that possible? No, right? Because integer data type is a different value and real data type is the different value. Okay, real data type, what we are seeing that like 0.5 or 2.5, 3.5, some decimal values, some floating values we are seeing. Okay, that floating values, how we can convert into integer? That is not possible. How you are equating to integer values? Integer values means 2, 4, 6, 7, something these values. Okay, so that's what. So incompatible data. So incompatible data types. An integer and real number are stored in differently, right? Integer value will be stored in different data type, and then real data type will be stored in different values. Okay, then I am not equating the two values, right? Same thing. Okay, integer is a whole number and real is the decimal number. See here 2, 4, 6, 8. In this way I am writing. Here 2.5, 4.5, 4.6, 6.7, 8.8. In this way I am storing the values. Then those two values I can't equate it. Okay, so that is the reason we are writing the what it called. Uh, we are taking some casting. Okay, casting is converting that one data type to another data type. So it converts into see just I if you are try to directly mix them, the information may get lost. Then casting tells that compiler, I know what I am doing. Convert it into this data type. Okay, so something you are saying, right? Sometimes, hey, what you are doing? So is that correct? So you are doing something wrong. Then you can simply say, I know what I'm doing. Okay. So then you can do your work, mind your words. Something we are saying, right? So then same thing here also it is taking that. Okay. So what you are doing, you are converting that. So integer data type you are taking, then you are converting to into real data types. Okay, so that's what I'm doing. So I know what I'm doing. Then you can simply convert it. So I want to use that data type only. Okay, so it is converting. Yeah. So convert this to convert into whatever the conversion you are saying that. So that conversion will be taking place. Okay. There are two types of castings: static casting and dynamic casting. You have seen already dynamic casting. Where you have seen. Dynamic casting where you are seeing in polymorphism, right? In polymorphism, you are doing that parent equal to child. That is up casting, and then down casting you are using the dollar cast. Dollar cast is the dynamic casting. Okay, that means child is assigned to parent. Okay, See, this is the basic syntax for the casting. Okay, what is your data type? Take some expression. Int is a data type. Take some real value. Okay, expression you are writing. Then here I am converting the real number to integer data type. Okay, int take 2.7. Then that should be converted to real number. Okay, integer number. That means 12 maybe I will take, or 2 maybe I am getting, or it should be round off to 3. Okay, that is the integer format. So real format to integer format I am converting here. So that for that 1 TB you are writing. See, because why always you are writing TB only? Because SB is a testbench code. Okay, most of the times I'm writing I'm checking my DUT. Okay, so that is the purpose I'm writing all the TBs. See, dynamic array TB only, associative array TB only, U is also TB, and then array manipulation methods also TB. Okay, so interface also there in TB, and then casting is also there in TB. Okay, all the things are represented in your test bench to verify single DUT. So to verify something, these many people are working together. Okay. So that is the reason the verification is little bit tough compared to the design. Designing means you what? You are designing something. Just I need to verify all the conditions, right? So you are coming to the class. Okay. Whether weather is not good, you are you coming or not? And then your health is not good, are you coming or not? And then your breakfast is not completed, are you coming or not? And then see, these are the scenarios I need to think about it. So around the clock I need to think, right? To verify something. Same way here also, the static casting, I'm just converting this real data type to integer data type. Real value I'm considering that should be converted into integer data type. It should be stored in integer value, integer handle I. Okay, understood, right? Casting. How I'm converting that. Same way, integer to real. Okay, integer to real, how we are converting that? Same thing. Real take some expression. Okay. So integer value you are giving 25. Then that should be converted into real value means 25.0. Okay. So then some decimal values will be getting. Understood, right? Hmm. Byte casting. That means I want to convert that byte format. Okay, whatever the data I'm taking here, that should be converted into byte format. So take the byte tick data. Okay, whatever the data I'm considering, that should be converted into byte format. So I'm taking the byte data here. Okay, and string to integer. Okay, string to integer means just you are taking the name that should be converted to integer format. Okay, then you will be getting the string integer value. Okay, so this is the type casting only. So what are the rules to follow casting? Static casting. I'm just following that. What is the conversion? Compile time is ticking. So the compiler verifies that legality. That means what you are converting. And then no runtime failures. Static cast never fails. Okay, so while casting something, it never fails. That is the no runtime failures we need to use, and may lose information while you are converting some real data type to integer. That may be lost some data because I may consider 10 or the simulator may consider 11. Then you are converting some data. So you are losing the data, you are gaining some data by conversion. Okay, and then packed array casting. What how you are converting that packed array means in your packing array, different data types you are using. Big data types you are using, byte data types you are using, and then integer data types you are using. All the combined together, and that should be packed. Okay. So see here I am using that logic data and then byte data. Okay. So this should be converted into um, bytes format. Okay, so that means byte data, bit data means logic data means it is storing that zeros and ones only. Okay, and sometimes it is also storing unknown value and high inference value. Okay, so here I am taking that 8-bit data. So that 8-bit data should be converted into that is an array format, right? So packed array. Okay, so packed array should be converted to byte format. Okay. And enum casting like typedef enum I'm taking that, so integer to enum I'm converting that. So how we are converting that integer to enum? So just state t hash 1 you are taking, that should be equal to state, so that state will be assigning to some string data type. Okay, so enum to integer to enums. Okay, that means you are taking some integer value, because in your enum the named constant values will be storing like 0, 1, 2, 3, like that, right? For 0 some name I am representing, for 1 and one name, and 2, 3, in this way I am writing some different names. Okay, so then it should be converted into enum data type. Okay, because I need to get some names, I am giving some integer values. That integer value should be converted into name based on that whatever the names you mentioned in your enum data type. Okay. Similarly, dynamic casting. What is that dynamic casting? Dynamic casting means in OOPS concept we are using inheritance time and then polymorphism time. So we are using this dynamic casting. That means I want to convert not for integer, real, and then byte, all these things. Just you are converting some parent to child and child to parent. Okay, the classes concepts will be applied here. Dynamic casting. Why dynamic casting is considered? Parent to child, child to parent. The parent handle is that parent p and can points to the child objects. Okay, that is inheritance. Parent handle is obviously showing the child properties means, because you are using this casting like p equal to c. So this is up casting you are taking. Okay, and then dollar cast you are using, but how we are safely convert it back, like the child properties to the parent, how we can access them through the child class handle. How can I access my parent class properties? Through parent class, how can I access the child class properties? That is the dynamic casting we are doing here. So how we are writing the dynamic casting? This is the destination and this is the source. Then you are using p comma c we are writing. Okay. Parent is the destination, child is the source. Okay. Then child class properties we are assigning to parent class. Okay. So that is the conversion is taking place. Okay. See, basic inheritance, we are using this P equal to C. Okay, in successful dynamic casting, P equal to C, that means the parent class properties are assigned to child class. Okay, and then C comma P, and then that means child class properties are assigned to parent class. Okay, so that's what we are doing the casting here. Okay, the destination is uh, parent, child, and source is parent. Okay, upcasting and downcasting. Upcasting, base class handle is pointing that child class properties, and downcasting, derived class handle pointing that base class. Okay. So why the dynamic casting is failed? Failed at dynamic casting. So because if casting C comma P, we are assigning that. Okay. Without assigning P equal to C, we can't do this one. C comma P. Okay. Previously, what we are doing here, P equal to C, I am taking that. Then only the successful casting will be happening. Otherwise, the downward casting is not happening. Okay, so P equal to C, you are not assigning means the dynamic casting will be the casting will be failing. Okay, so dynamic casting function. See here, if dollar cast child handle comma parent handle. Okay, that means runtime crash. Okay, so what is that? Because the destination and source will be before that, we need to do this upcasting. After that, you can do the downcasting. Then only there is no crash will be occurred at the runtime. Otherwise, runtime crash may occur and your data may not be received. Okay, so without checking return value, so we are not getting the value. So the simulated runtime error we are getting, because if it is invalid, why it is invalid? Destination comma source we are taking place, but that is the older style. We need to assign that P equal to C, then only we can assign that destination comma source downcasting we need to apply. Okay, just take this summary. Let's see this program related to casting. Just I am converting that module casting example enum data type I am considering here. Okay, enum integer red, green, blue, white. Some handle is color P. Okay, and also parent class animal I am taking. So string name is animal. Okay, I'm just displaying that string in my parent class. And the child class, from the animals I'm derived that class is dog. Okay, so then function new name is dog. Okay, so then the child class display, we are displaying this constructor by name. Okay, so just I'm taking them. And similarly, another child class, that is derived class from the animal cat, I'm deriving it. Okay, and then constructor new, in that name assign that and displaying the name. Okay, so in through constructor also we can assign the strings. Through constructor also we can assign the values. Okay, then variables you are considering integer I, real R, string S, color handle, that is enum data type you have considered, right? For that you need to consider the handle for that. Okay, so color P, handle color, and animal, that is the parent, and dog, in dog, cat is the cat you are taking. Okay, so then casting I am doing here. Initial begin. So static casting I am doing here. Real value I am taking here 12.75. What is the integer value? Some 12 or 13 it is taking place. Okay, so real to integer conversion, real value I'm displaying. For that, I'm displaying the integer value. Same way, integer I'm considering 50, that should be converted to real value. And then string I'm considering, that should be converted to integer, string to integer. Okay, and then real number I'm taking that, that should be added here, casting. Okay, so here I'm taking that 4 tick hexadecimal A, that means real expression the floating values will be taking place. So hexadecimal address I'm taking there, that is the real integer values that should be converted to real. Okay, and then enum2, that means strings to integer values. Okay, so some enum value string name color dot name, because I'm giving the integer value, integer to enums I'm converting. Okay, similarly dynamic casting. Hmm. See, you are not assigning that parent equal to dog, that means parent equal to child. This downward casting is not possible. Dog comma parent is not possible. Okay, so then dog dot display here. Okay, similarly, I'm taking that dog comma parent, and then just give me a minute. Okay, ikkada, sorry. Um, we are using the downward casting here. So if $cash dog comma parent and initial begin, dynamic casting is successful. Okay, so dynamic casting function we are taking here, and then failed dynamic casting, that means parent equal to cat, and then if dog comma parent we are taking. Okay, so previously dog comma parent we have considered here, and then the parent equal to dog we have considered, and then $cast is successful here, and dog dot display. So why here it is failing that dog comma parent, because here not casting something, just we are casting that cat equal to new. So parent equal to new I'm not creating. Okay, so this dog equal to new you are creating, that means child class, and then here uh, cat equal to new you are creating, and then uh, for the child class you are creating the object, and then assigning the parent to child, but the child is changed here, dog comma parent you are taking. Previously, I'm taking the downward casting. So dog is a child class, and parent to child I'm casting that, and child to parent I'm casting here. Okay. So then same child, same parent we are considering. But here child is missing. That is the reason the downward casting is failing. Okay. So you are assigning the object to the cat, but you are casting to the dog. Okay. Dog dot display. Okay, clear? This is the casting. Okay, up to that we are doing the some casting here. Okay, then just run this program. See, first one, what is the display we are getting? Up to this we are taking the signals only. Okay, parent class and all these things, and then where we are taking the variables from here. Okay, static casting. So from the static casting, starting from static casting. Okay, here I'm taking 12.75, that should be converted to integer. See, integer 13 it is taking. 12.75, that should be rounding off, and we are getting the value is 13. Okay, and then integer value, I told you no, so just it is taking some point values, 50.000 something. That should be converted to decimal values, and then ASCII to integer. Okay, ASCII value is what is the value of ASCII for A? Is a 65. It is taking that. That means I am considering here string that should be converted to integer format. Okay, that means int of string. Okay, for you are converting which data type, you need to write that data type first. Okay, you are converting string to integer, then I need to write the integer tick. Which data type you are converting? String data type. That string to integer I am converting. Inside the brackets expression, you need to write the string data type. Okay, understood, right? And then enum data type. Enum data type I am converting here. So what is the enum data type you are taking? See, 2. 2 means this is 0, red is 0, 1 is green, 2 is blue. So blue should be converted to some integer, some other value, like the blue value I need to get here, right? So because color dot name I am getting. Okay, so here I'm giving the integer value that should be converted to enum. Okay, see, blue I got it. Enum casting, integer enum value is blue. Okay, same way dynamic casting. See, dynamic casting, dog is a derived class because you are displaying that dog. Okay, so where you are creating the object here, so virtual class is not there, means whatever the object you are considering. See, your parent you are considering the virtual or not, function is virtual or not. See, not virtual. Okay, so not virtual, you need to consider the virtual function here. Okay, here I am not taking the virtual function, then it depends upon the handle display. Okay, you are displaying the dog.display, then I am getting the dog. Okay, dynamic casting is successful here because the casting is done parent equal to dog here. Okay, so and then dog comma parent, dynamic casting is successful, dog dot display, I mean dog, derived class is dog. Okay, similarly failing dynamic casting because parent object containing cat. See, object is cat you are creating, but you are assigning that dog here. See, here you are creating the object for cat, but you are assigning that dog. It's not possible. That is the failure case. Understood, right? Casting. So next package. Okay, how the package is converting. So what is the use of package? Okay, so think of a package as a shared toolbox, like you are connecting all the modules and keeping it one place. Okay, so in your package you are writing your classes like driver class, monitor class, generator class, and then scoreboard class, and then test environment. All these classes you are designing. Okay, so individually you are writing some classes. Okay, all the classes are keeping at one place, that is a package. Okay, so every module copies the codes like duplications. Then maintenance should be a nightmare. Okay, so that is the reason we are writing different classes. See, file A has been transaction class, file B is an enum class, and file C is the some utility functions. Without package, we need to keep it every one individual. Okay, with the package, put everything in one toolbox, that is a package. See, classes will be placed in one place, enums will be placed in one place, parameters, functions, tasks, and typedefs. All the things are keeping at one place, that is a package. See, uh, you're doing recharge for some internet. Okay, they will give you some packages. Okay, 779 rupees or 780, 750 rupees. 750 rupees that all the apps also we are getting some subscriptions like Geo Hotstar, Netflix, and then all these things. We all are tie up with these networks. Okay, so then they are also we are giving indirectly the money to these Netflix and then Amazon Prime, all these things. Okay, so and then Geo Hotstar. But because you are recharging every month, your need, okay, then they are caching. Okay, so same thing here also. uh, all the things are grouped together at one place. Okay, how these networks were packaging, right? So same thing, the package is also grouping that different classes, different functions, different enums, all these things. Okay, imagine 100 engineers are working in a UVM environment. So they are needing that transaction class, packet class, state enum, address, and all these things. Then we need to keep 100 copies. Okay, 100 copies is that is huge, right? Everyone 100 copies are taking place means that's a problem. Instead of that, we are giving some package. So that's what stored in one common place, that is a common package. Then we will import all the packages. So in your UVM, you will see this type of syntax import. Okay, so import my package, scope resolution star. What is the use of scope resolution operator? Okay, we can point out where we are exactly going. I have explained already. So scope resolution operator, she is staying in one apartment and then in that one flat, she is saying that. Directly she is saying that Prestige apartments and then block B, and then in that block B, second floor, 105 floor number. Okay, apartment number. Then I can go directly. Same way, this scope resolution operator is getting the things directly where we are exactly there. Okay. Same thing. The package we are keeping it one place. We are importing that package. In package, some particular value also we can get that. Okay, so whatever the values are there, suppose data width is there, this data width I want to import it, then import my package scope resolution data width. Okay, so in this way we will grouping together. Okay, same thing, package, simple package I am representing, package, math package, inside that data width, integer width, and then end package. Not only single value, you can represent all different values, some enums and functions and all these things in your package. You can write it. Then just in your module, you can import this package. Then you will directly getting this width. Okay. So in packages, you are representing width, depth, address width, address depth, and then write enable data type, integer data type, all these things. Okay, all these things I am keeping at one place. I am writing it. I'm calling in my test bench. Okay, so just importing that package. Import math package scope resolution star. Okay. Same package with functions. You are writing some addition function here. Return add value. Same thing I want to utilize in my TB. Just importing the package. You are directly giving the calling the function value. That function you are adding the values to that. Then you will be getting that addition value. Okay. Output should be written that addition value. Package with tasks also, task print message string message. So just I'm taking the string message, so you are writing print message is hello. Okay, your string is message, right? So then what is your task name? Print message. While calling the print message, you are writing that hello, this hello will be stored in message, that message will be displayed here. How I'm getting the value message hello, and package with parameters. So you are writing address width, data width, and width, depth, all these things. Okay. So just you are writing width is at some 64 and depth is right 128. Okay. You are importing the package. Just you are writing the address width and then data width for the data. Then it is getting directly. Still, you are not mentioning any parameters in your module TV, but you are operating with that address width and data width and depth. Okay, so that's what package with enum. See, enum data type I'm utilizing here. So in this enum data type, I'm writing that values like names like idle, busy, done. Through this handle, I'm calling this. Okay, so then dollar display some state name. State name means state is the handle, right? You're equating that handle equal to busy. This busy will be there in your enum. Then enum having some inbuilt functions, name, number, and then first, last, next, previous. Okay, all the things will be displayed here. Okay, because you are importing that enum data type in your TV. That enum is writing in your package. Then your package is importing in your TV. That package will be getting that whatever the data types you are written in your package. Okay, just a single line will get all the data into your module. Package with struct. Struct data type also I am writing. Struct is the collection of different data types. Okay, and union collection of different data types but sharing the same memory. That is the difference. Struct and union. Both are same collection of different data types, but struct is having individual memory. Each and every data type stores their own memory, but union all the data types are stored in the same memory. Okay, that's what. Package with class also. In class, I am representing all the data, and then that should be written inside the package. Then I will import this package in my TV. Okay. See, same thing. Transport module TB transaction package. So import transaction package. This is your class name. Sorry, package name, right? Transaction package is the package name. That package name I'm calling here my TB. Then transaction handle I'm taking directly. Based on that, I'm randomizing that. Just calling the print function here. Okay. So see transaction dot print, that is the inbuilt method. Okay, whatever the data you are writing in your TB, okay, that will be displayed like a tabular format, like name, value. Okay, so value comma name comma size comma. Okay, this data type comma. Okay, all these things are displayed in your tabular format. Okay, while you are calling that transaction.print. Okay, so import everything. So you are importing like this import. Okay, package. So packet package, some package, CPKG. Scope resolution star you are representing means it imports all the data types. Okay, all the packages or whatever you are writing in your package, all the things will be input all symbols available in your classes. Okay, because you are writing in one place. So for your handle I am writing in one class one package and her handle and your handle and all the handles are writing in one handle one package. Then I will import the one package. Then all the persons are coming to that module TB. Okay, in your TB we are getting all the things. Importing one item. So if you want to import one item, you can import it. So import package transaction. Then so import only transaction class. Whatever the transaction is there, that class only we are importing. Star is represented means all the things are importing. Okay. Similarly, scope resolution operator. What is the use of scope resolution operator? we can access directly. Okay, whatever the classes in your class, some static members are there, static functions are there, or static tasks are there. Okay, all the things you want to access in your TV without creating the object, we can use this scope resolution operator. Okay, by using the scope resolution operator, we can get all the data, whatever the data are there in your class. Okay, that should be getting at the TV side by using the scope resolution operator. Okay, that's what. By using package, and then scope resolution transaction TR. Then this is the class name, transaction class name. Then we are getting the transaction directly. Or package scope resolution width. So you are importing all the widths. See here items will be getting, and here some library. Library means package library. In that package everything will be there, right? So all the things are I'm getting here. Suppose you're rating something on the library, so that means the whatever the writing things in your library I want to use in my TB side, then I can use it. Okay, so package configuration package here. Inside that data bit I'm representing. This package I'm importing in my class, or using the scope resolution operator I can get it directly. Okay. Nested packages like see package A. This handle I am representing in my package B. That means package B is there. Then in that package B, whatever the package A is there, that is also available in package A. Now I want to import all the packages. Then I can call the package B. I can call the package B in my TB, then I will get package A also, because in package B, package A data also available, right? So that's the reason I'm taking it. Okay. Same thing. This is the reusable verification type def, and then parameter address width and class we are taking. So all the things are writing in one package. That is the common package. Then I can import all the data here. See, functions I have written, classes I have written, type def I have written, and parameters also I am considering. All the things are placing it one place, that is the common package. I will import this common package in my TB. Then all the things are coming here. Here. So then you are randomizing the transaction, print that transaction, and then dollar display checksum. That checksum is that related to your function, and then function will be returning that addition value, and then you are getting the parameters like address width and data width. That is also getting. All the things are coming in your TB. Okay, just read this package. What is package and why we are using this package? So package can store parameters, enums, typedefs, struct, functions, tasks, variables, classes, all these things. Okay. Instead of importing all the things, all the individual things in your TB side, I will keep it in one package side. Then I will import that package in my TB side. I can also use scope resolution operator. By using the scope resolution operator, we can import all the values in your TB. So then package is a shared resource tool or shared library or shared toolbox. It can share that whatever the data are there, it can store. Just take some break. See package A. In that parameter width I am taking, int data I am taking, and then type def. Okay, so type def data I am taking here. Okay, so here I'm writing enum also, type def enum, and then class. In my class, int address and w data I'm writing and displaying the values. Okay, and function void show package. In that, I'm inside the package function data I'm writing here. Okay, and then task show task inside task. Just I'm calling that. And similarly, another package is I'm writing package B, and I'm importing all the package classes. Whatever the package A is there, all the things are importing in my package B. Okay, so integer version, some version I'm writing here, and then dollar display, sorry, function void display inside that package B, the some version I'm printing and package. Similarly, I'm taking another package C. Okay, so then importing package B in package C means I'm importing package A, package B in my package C. Okay, and you are writing some string names like OpenAI, and then some function you are writing in the package, third package. So now you are writing three packages. So then third package C, package A and B also there. Now I will get the all the packages in my package C. Now I will import package C in my TB. Then I will get all the packages. See, so import package A. So that means package A only we are importing, and then package C info message info I am importing. That means specific item I am importing. Then instead of package A, you can also import package C. Okay. So but here I am importing package A only. Okay. That package A getting the different data, and package C also I am importing that. Then all the data will be there. In specific info only I'm importing. That info is having transaction and temporary data, all these things, and displaying the packages. Okay, parameters also displaying here, typedef also displaying here, enum also displaying, and class I'm giving the data, and show package, task I'm calling, functions I'm calling, and scope resolution operator, show package, display, and info. Okay, all the packages will be displayed. See, then you are displaying that package A, and then package B, and package C. Just run this one. What you are getting the output. See, the data is came here. So package variables, data values, and parameter width, type def AA. So whatever the displays you are taking, all the things are appear here. Okay. So first package is display package variables, right? Importing everything. Uh, This is the package variables. Inside that package variables data I am displaying. What is the data I am giving here? So this data I am giving 100. Okay, 100 I am getting. Okay, so then another value variables completed, package variables, everything is importing here, and variables, package variables are completed. After that parameter width I am taking, then width I am printing here, and then type as sorry, temporary variable I'm taking that AA. So then type def temporary display I'm getting that. So AA will be displayed here. And enum data type read state I'm printing. Then read dot name. Then state is read, you are reading. And the class we are considering this class transaction dot display, what you are displaying, show package. Okay, show package you are writing in the class B, right? So function void display. So show task is this, and show package in class A only, package A only we are writing that. So inside data, that means data is 100. So and then inside the package function data is 100. Okay, and then inside that package task A. Okay, the task A is also getting that. And then next is scope resolution operator. Parameter type def is completed, renum, and then class is also completed, task and scope resolution operator. displaying that package and then display info. So you are displaying directly inside the package data, and then display means task B, and then version we are printing inside the package A, and then package A all the things are displayed here, and then package variables. Okay, clear? So you are printing all the variables package A, package B, and then package C. Package A variables all are displayed here. Okay, so and then pack inside the package A, and then inside the package A function. After that, package B function. Just read this program, then you will get one idea. Okay. Next one, compiler directives. What is compiler directives? All these things. You know already in Verilog we have seen the compiler directives like tick define, tick include, tick if defined, tick if not defined, tick else, all these things. Okay. Same thing here also we will see the compiler directives. Why? What is the use of compiler directives? So the compiler directives has the instructions to the compiler before actual compilation starts. Okay, if we are starting the compilation, then we are giving that some compiler directives. Okay, so then these are not creating any hardware. Okay, just before compilation, it will execute all these things. Okay, some syntaxes we are adding. Okay, by using this compiler directives. Okay, so how we are assigning that? Some widths I'm adding that. So parameters you are taking that. Okay, I'm using this tick define width. If you want to override this one, how you are overriding? Like dot width of some 64. Name based overriding you are taking. Or define params you are taking. Diff params. Okay, that means define param. In this define param, you are changing the width. Okay, width equal to 64. This is the old style, and the new style we are taking that name based instantiation. Okay, whatever the parameter you are considering, that module name you can take that. Before that, you can take the module name dut and you use a dut. Inside that, you can write the parameters list. Okay, then you can override the parameters. And also we are including the classes like tick include transaction.sv. Okay, I'm including that. Including means copy paste somewhere else this transaction class is there. That transaction class I'm writing in my TP. Okay, so now why we are taking this compiler directives means, so you are writing generator class, and then driver class, monitor class, scoreboard class, agent class, environment class, and test. All these classes are keeping at one place, that is top module. Okay, so then I'm including that. Tick include transaction.sv, tick include generator.sv, tick include driver.sv. Then all the classes are placing at one top module. Then in top module, I will execute all the classes. That is the thing. That is the reason we are using this compiler directives. Okay. So tick include compiler directives. We can take that. So pre-processor runs. That means during that compilation, it is before that only tick include, tick define. All these things are executed. Okay. Then expanded code that generated. How we are expanding? Compiler compiles that expanded codes. Whatever the expanded codes are there, that will compile C. Okay, before entering into the simulation, then the compiler will compile all the compiler directives. Okay, then compiler directives, text manipulation, compiler. They do not create any hardware. Remember, compiler directives are not creating hardware. Just some parameters you are importing, some classes you are importing. Okay, so those are not creating any hardware. Okay, what is use of tick define? What is the use of tick define? Tick define is a text replacement. Like tick width, you are taking that. Then you are defining that tick define. Okay, width. Then wherever the width is there, I will use this tick width. Okay, tick width minus 1 down to 0. Then whatever the width you are mentioning in the define files, that width will be coming here. 16 minus 1 down to 0, that is 15 down to 0. Okay, so that's what. Okay, so tick define name replacement text. What is the name replacement text you are replacing? So tick define width. Okay, instead of width, previously you are taking like width minus 1 down to 0. But I am taking tick width minus 1 down to 0. Then whatever the width you are considering in your defines files, that value will be placing in your classes. Okay, so that is the simple macro we are using, that tick define. Okay, this tick define is a width. Then in your TP also you are using this define files, tick defines.svh files we are using. That means system verilog headers. Okay, that headers will be placing one place. And constant macros like parameter depth and tick define depth, and then memory depth, and then int memory depth, whatever the depth you are assigning, that value will be takes place here. Just replacing the text. Instead of parameters directly writing the parameters, I am replacing the text. Inside the text, it will be getting all the arguments. Tick define macro arguments like tick define add a comma b. Okay, so that means addition is a macro. Okay, so remember all the macros are represented in the capital letters. Okay, so add is a macro, then I can use that add directly, then results is that a plus b is doing here. And similarly subtraction also you can do that, multiplication also you can do that, addition also you can do that, division also you can do that. All the macros we can include that. And parentheses like square brackets, so squaring of a numbers. Okay, without squaring, how it will be taking here? See, just square of x you are writing. Square of x means x into x. Okay, x square, that means 2 is taking means 2 square value you are getting. Okay, same way, this parentheses are not there means 3 plus 2 is means 5, right? 5 square is 25. But how it is doing here without parentheses? So 3 plus 2 into 3 plus 2. Okay, then here multiplication is doing first, after that addition. 3 twos are 3 twos are 6. 6 plus 3 plus 2. Then what is the answer? 11. But what is the answer? Actual answer 25. Because of the parenthesis we are changing the values. Okay, see, that is the reason they are adding the parenthesis inside the square numbers. Then 25 we are getting. What more still you know, right? Brackets of division, multiplication, and addition, subtraction. Okay, so that's the things are following by the computer. Okay, so same thing here also, macros parentheses we need to use that. Without parentheses it will take different values. And backslashes, like backslashes, what is the purpose you are taking that? Backslash some company names you are separating. Okay, so string macros, some tick define company Nvidia, so Nvidia you are getting that. Okay, or Qualcomm you are getting that. Some backslashes we are saying that, so line separation. Okay, so backslash n, new line we are getting, backslash t, tabs we are getting, spaces we are getting. And macro logging, that means info messages we are writing. In UVM we are taking tick UVM info. Okay, This info message is like a dollar display message. Okay, how we are using dollar display in sp, same way tick info we are writing, so that info messages we are displaying purpose, we are using displaying purpose. Okay, and then macro for error reporting, like reporting objects are there, like tick error. Okay, that means error we are getting, or tick warnings. Okay, warnings we are getting, a tick fatal. Fatal error is came means the simulation will be terminated immediately. Okay, so that is the use of some macros reporting here. Okay, tick errors, tick warnings, errors reporting here. That means tick define debug. This is already tick define file, and tick if define. Tick if define means here we are defining the debug, then only it is taking the debug value. Whatever the defining files you are defining, then tick if define. If the defined file is there, it is working. Okay, and tick if not defined. Tick if undefined means not defined. Whenever you are not defining, then it will work. Okay, whenever you are not defining the defined files, then it will work. Okay, that's what reverse condition. Same thing is there. Debug mode, tick if defined, some copy paste method. Tick include, what is the use of you are taking that? Tick include is nothing but one file is there somewhere else. Okay, file.sv is there. Tick include file.sv means that file.sv will be added in your TB side. Okay, so that is the tick include. See, transaction.class is there. Transaction.class is there. I'm including this transaction class. A tick define transaction.sv. Tick define transaction.sv. So if not defined, it will work that. If defined means it is working. Okay, remember this. Same thing. The class is represented somewhere else. Entire class things are represented here. We are getting. That is a tick include. Okay, tick include transaction class is there here. Okay, so see here also I am including in my module TB. Before that I am including the TB file, transaction.sv file. Package also there, right? Package is also importing that, but it reference for symbols and no copy paste. It is importing that, but it include it is copy paste. Okay, there also copy is there and pasting here. Okay, that is the purpose we are using tick include versus package. And verification package plus include, like class transaction end class, class driver end class monitor end class. So three different classes are there in your package. All the files will be including. Then I will import the package. Then while importing the package, all the classes will be appeared in my TB. Okay, just import TB package. This is your TB package name. Inside the classes we are representing. So then I will get all the values. Okay, so this is the macros we are defining. So this macros will be takes place. So just see this code. It takes some time. See this code related to Mac compiler directives. Tick time scale, right? Time scale. I'm using that 1 nanosecond by 1 picosecond. 1 nanosecond is the time unit, and this is the precision. Okay, so that means every time 1000 delay will be added for each and everything. Okay, see, tick define data width is 32. Okay, so then this addition file will be taking that width is 32. Okay, every variable is taking that width is 32. Tick define, add, subtraction, multiplication, division, and maximum values. All these things are some parameters. I told you, right? So macros, addition macros, subtraction macros, and then division, all these things. And then multi-line macros. Okay, this is simple macros, and then multi-line macros. What is that multi-line macros? like backslashes I'm using them. Okay, these backslashes will display that each and every line separate line. Okay, like name, age, salary, we are displaying that. In the info, display message, tick define, display info. This display info, name, age, salary, we are displaying that. Okay, so directly I'm giving the display message, then I will get the display values. And then string macros, like names we are writing, tick define greeting. Greeting is the some string. Okay, it will display that hello. Okay, what is the greeting? Hello, I'm saying that hello. Okay, percentage less, welcome to system verilog. Okay, the name we are printing. Okay, whatever the name we are printing, that will be appeared at the output side. Function macro, that means defines. It defines color value, color, and decode it. Some color we are decoding it because we are writing some colors somewhere else. Okay, you are defining here. And then class transaction I'm writing here. In that my class address and data I'm taking and displaying the address and data. And then module, the compiler directives demo. So that means just I'm taking the module. Before that I'm mentioning all the things. Okay, so inside the module, enum data type I'm writing, and then function I'm calling here. See, color you have taken, right? So that is the color handle you are considering. Type the color you are considering. That color value will be red, green, blue, yellow. Written that some values. Okay, and then transaction class you are written, class transaction int address and data you are taking here, ab I'm writing. Okay, now displaying that defines file simple macros data width I want to display it, and parameterized macros I want to display it, some addition, subtraction, multiplication I'm displaying here, and multi-line macros I'm displaying. In multi-line macros I'm writing my name, age, and then value. Okay, functional macros I'm writing that red, green, blue, yellow I'm calling here. Okay, tick color value. Okay, so see, the colors are different whenever you are using the tick. Where you are seeing the tick here, see in your keyboard. So after the tab there is a slant line is there, that is the tick. Okay, you need to use the tick, not apostrophes like single quotation, don't use that. Okay, this is the transaction class. And sequence you are writing. Macro substitution, like addition, subtraction, multiplication you are doing, right? All the values we are substituting. Then run this one. Compiler is successfully completed. Completed successfully. See the display. Simple macros display we are displaying first one. So this is simple macros. Simple macros here. Uh, what you are displaying, address and data. So width is displaying them. Take width 32 and 10 taking. Then display I got that. Parameterized macros. So addition, subtraction you are doing 50 comma 20. Add a comma b 70 got it. Subtraction 30. Multiplication some 1000. Okay. So all the values we are getting. And then multi-line macros. Multi-line macros means just I'm taking the name, age, and salary. Okay, so that multi-line I'm considering here. So then I got the name and then age, salary. Okay, so then function macros. Functional macros means red, green, blue. You are calling the colors, right? So we are displaying the all colors here: red, green, blue, yellow values. And then string macros. String macros means greetings I'm doing here. Okay, so that greetings just I'm commenting that one. So just if you uncomment it, you will get the name here. And then class macros like transaction new address and data we are giving. Address is 100, data is 999. Escape sequence. So escape sequence means new lines. See line 1 and then line 2. Both are new lines we got it. Backslashes. And tabs we are getting. Okay. most of the industries they are using these backslashes. Okay, they want to give some spaces to this one ABC printing here, and macro substitution like addition, subtraction, multiplication you are doing, right? Those values we are getting here. Here, compiler directives.